Good morning, everyone. Myself, Kumar. Let me all welcome you to this webinar series in commemoration with the World Environment Day 2020. EMC is going to present a webinar series of which will be extending to over a period of 10 months in different sectors, regarding different sectors, energy usage. Let me introduce our director, Dr. R. Kumar, to talk with you about this program and today's regarding today's webinar program. Thank you.
Good morning. Is it audible? Audible. Okay. Yes. Good morning to all from Energy Management Center. Myself, Kumar. The next technical session is on English, so I will just start speaking on Malayalam for about 10-15 minutes. എല്ലാവർക്കും നമസ്കാരം. ലോക പരിസ്ഥിതി ദിനത്തിൽ ഈ എനർജി മാനേജ്മെന്റ് സെന്റർ ആരംഭിക്കുന്ന വെബിനാർ സീരീസിലേക്ക് സ്വാഗതം. ഞങ്ങൾ ഇതിന്റെ ട്രെയിനിങ് കലണ്ടർ ഇന്നലെ ബഹുമാനപ്പെട്ട വൈദ്യുതി വകുപ്പ് മന്ത്രി പ്രകാശനം ചെയ്യുകയുണ്ടായി. ഈ ട്രെയിനിങ് കലണ്ടർ എനർജി മാനേജ്മെന്റ് സെന്ററിന്റെ വെബ്സൈറ്റിൽ അവൈലബിൾ ആണ്. ഇനി വരുന്ന 10 മാസം, ഈ ഫിനാൻഷ്യൽ ഇയറിന്റെ 10 മാസം ഏതാണ്ട് 220 വർക്കിംഗ് ഡേ ഉള്ളതിൽ നമുക്ക് 150 ദിവസത്തോളം നീണ്ടു നിൽക്കുന്ന വിവിധ ബോധവൽക്കരണ പരിശീലന പരിപാടികൾ, കപ്പാസിറ്റി ബിൽഡിംഗ് പ്രോഗ്രാംസ് ഇതിനകത്ത് ഉണ്ട്. മിക്കവാറും എല്ലാ സെക്ടേഴ്സിനെ അഡ്രസ് ചെയ്യുന്ന രീതിയിലാണ്. അതിന്റെ തുടക്കമാണ് ഇന്ന് നമ്മൾ ചെയ്യുന്നത്. ഇതിനു മുമ്പ് പൈലറ്റായിട്ട് ഒരു 2 പ്രോഗ്രാം ചെയ്തിരുന്നു. 16-ും 17-ാം തീയതി മെയിൽ ഇന്റർനാഷണൽ ഡേ ഓഫ് ലൈറ്റും വേൾഡ് ടെലികമ്മ്യൂണിക്കേഷൻ ഡേയുമായിട്ട് ചേർന്ന് നല്ല പ്രതികരണമാണ് ലഭിച്ചത്. IIITMK എന്ന് പറയുന്ന റീസെന്റ് ഇറ്റ് വിൽ ബി അപ്ഗ്രേഡഡ് ടു എ ഡിജിറ്റൽ യൂണിവേഴ്സിറ്റി. അവരുമായിട്ട് ചേർന്നിട്ടാണ് നമ്മൾ ഈ പ്ലാറ്റ്ഫോം ഉപയോഗിച്ച് ഈ വെബിനാർ സീരീസ് നടത്തുന്നത്. ഇന്നിപ്പോൾ ഏതാണ്ട് 66ഓളം പേര് ഈ വെബിനാറിൽ നമ്മൾ പങ്കെടുക്കുന്നുണ്ട്. വിവിധ സ്ഥലങ്ങളിൽ നിന്ന് എല്ലാവർക്കും EMCയിലേക്ക്, ഈ പ്രോഗ്രാമിലേക്ക് ഒന്നുകൂടെ സ്വാഗതം ചെയ്യുകയാണ്. ഇന്നത്തെ പ്രോഗ്രാമിന്റെ പ്രത്യേകത എന്ന് പറയുന്നത് ഡിസൈൻ സ്റ്റേജിൽ തന്നെ എനർജി എഫിഷ്യൻസി എന്നുള്ളതാണ് നമ്മുടെ ടോപ്പിക്. ഈ ടോപ്പിക്കുമായിട്ട് നമ്മൾ സംസാരിക്കുന്നത് ഡോക്ടർ ജെ നാഗേഷ് കുമാർ, ഫോർമർ ഡയറക്ടർ ഓഫ് നാഷണൽ പ്രൊഡക്ടിവിറ്റി കൗൺസിൽ. ഹി ഈസ് ബേസ്ഡ് ഇൻ ചെന്നൈ. അദ്ദേഹമായിരിക്കും നിങ്ങളോട് സംസാരിക്കുന്നത്. അതിനു മുമ്പ് എനിക്ക് 1-2 കാര്യങ്ങൾ പറയാനുള്ളത് പറഞ്ഞ് ഞാൻ അദ്ദേഹത്തിന് മൈക്ക് കൈമാറാം. ഞാൻ ഇവിടെ തിരുവനന്തപുരത്തുള്ള എനർജി മാനേജ്മെന്റ് ഇൻസ്റ്റിറ്റ്യൂട്ട് EMCയുടെ ഓഫീസിൽ ഇരുന്നാണ് സംസാരിക്കുന്നത്. ഇപ്പോൾ നമുക്കറിയാം, കോവിഡുമായിട്ട് ബന്ധപ്പെട്ട് ഇപ്പം പോസ്റ്റ് ലോക്ക്ഡൌൺ പീരീഡ് വരുമ്പോഴത്തേക്ക് നമ്മൾ പ്രതീക്ഷിക്കുന്നു ഇന്ത്യയിൽ ധാരാളം ഇൻഡസ്ട്രീസ് വരാനായിട്ടുള്ള സാഹചര്യം ഉണ്ടെന്ന് നമ്മളൊരു പ്രതീക്ഷയുണ്ട്. കേരളത്തിലേക്ക് മടങ്ങി വരുന്ന പ്രവാസികൾ നമ്മളിവിടെ ചില എന്റർപ്രൈസസ് സ്റ്റാർട്ട് ചെയ്യാനായിട്ടുള്ള സാധ്യത നമ്മൾ കാണുന്നു. അത് ഒരുപക്ഷെ ഇൻഡസ്ട്രീസ് ആകാം, ഫുഡ് പ്രോസസ്സിംഗ് സെക്ടറിലുള്ളവർ ഇൻഡസ്ട്രീസ് ആകാം, അഗ്രികൾച്ചർ മേഖലയിൽ പുതു സംരംഭങ്ങളാകാം, കെട്ടിട ഹോസ്പിറ്റൽസ്, IT ഫേംസ് തുടങ്ങിയ ആകാം. അപ്പോൾ ഇതിലെല്ലാം ഡിസൈൻ സ്റ്റേജിൽ തന്നെ എനർജി എഫിഷ്യൻസി ഉണ്ടാകേണ്ടത് ഉള്ള ഒരു ഇമ്പോർട്ടൻസിനെ കുറിച്ചും അതെങ്ങനെ ചെയ്യണം എന്നുള്ളതിനെ കുറിച്ച് ചില കേസ് സ്റ്റഡീസ് ഉൾപ്പെടെയുള്ള കാര്യങ്ങളാണ് ഇന്ന് നമ്മൾ ഇവിടെ ചർച്ച ചെയ്യാനായിട്ട് പോകുന്നത്. It will not be going, the technical session will be in English, but since I am doing the introductory remarks, I thought we will speak in Malayalam because a lot of Keralites are also are there in the session. That is why I am speaking in Malayalam. We will shortly change over to English when the technical session starts. Okay. അപ്പോൾ പിന്നെ അതിന് പിന്നെ ഉള്ള പിന്നെ സംവിധാനം നമ്മൾ ആദ്യമേ ഉണ്ടാക്കണം എന്നുള്ളതാണ് ഞങ്ങളുടെ ഇന്ന് വയ്ക്കാൻ പോകുന്ന നിർദ്ദേശം. കാരണം നമ്മൾ പലപ്പോഴും എനർജി ഓഡിറ്റ് ചെയ്യുമ്പോഴത്തേക്ക് ആഫ്റ്റർ കമ്മീഷനിങ് ഓഫ് ദ ഇൻഡസ്ട്രി, മേ ബി ആഫ്റ്റർ 3 years or after 30 years, when you do energy audit, we come to notice that there are a lot of areas where you can improve your energy efficiency. And നമ്മൾ പലപ്പോഴും ഒരു 25 HP മോട്ടർ കണ്ടിട്ട് പറയും it is undersized, it can do the job if you have a 7.5 HP motor. Then the option പമ്പാണെങ്കിൽ നമ്മുടെ മുന്നിലുള്ള ഓപ്ഷൻ എന്ന് പറയുന്നത് either you go for undersizing, അതിനെ പമ്പിനെ മാറ്റി വയ്ക്കുക, അതല്ല എന്നുണ്ടെങ്കിൽ അതിന്റെ ഇമ്പല്ലർ ട്രിം ചെയ്യാന്നുള്ള ഓപ്ഷനിലേക്ക് പോകും. അതുമല്ല എന്നുണ്ടെങ്കിൽ we go for the fancy idea of variable frequency drive. ഇത് വേരിയബിൾ ഫ്രീക്വൻസി ഡ്രൈവ് എന്ന് പറയുമ്പോൾ വേരിയബിൾ സ്പീഡ് ഉണ്ടെങ്കിൽ മാത്രമേ ഈ വേരിയബിൾ ഫ്രീക്വൻസി ഡ്രൈവിന്റെ ആവശ്യവും വരുന്നുള്ളൂ. ബട്ട് ഇറ്റ് ഓപ്പറേറ്റ്സ് അറ്റ് എ കണ്ടിന്യൂസ് സ്പീഡ്, അറ്റ് എ കോൺസ്റ്റന്റ് സ്പീഡ്, and if require less than 7.5 HP load, then we have to undersize. അപ്പോൾ വീണ്ടും ഒരു ഇൻവെസ്റ്റ്മെന്റ് വരുന്നു. ഈ VFD ആണെങ്കിൽ another investment, and it will create some other pollution related aspects also. അപ്പോൾ ഇതൊക്കെ ഒഴിവാക്കാൻ വേണ്ടി നമ്മൾ ഇൻഡസ്ട്രി സ്റ്റാർട്ട് ചെയ്യുമ്പോൾ നമ്മൾ എന്റർപ്രൈസ്, ഇൻഡസ്ട്രി ആയിക്കോട്ടെ, അഗ്രികൾച്ചറൽ പമ്പിംഗ് ആയിക്കോട്ടെ, ഏത് എന്റർപ്രൈസ് ആയാലും ഇത് സ്റ്റാർട്ട് ചെയ്യുമ്പോൾ കറക്റ്റ് സൈസിങ് for energy efficiency. It reduces your initial investment, it reduces your recurring cost. നമ്മൾ പലപ്പോഴും പറയുന്നത് പോലെ ഒരു മോട്ടോറിന്റെ അല്ലെങ്കിൽ ഒരു പമ്പിന്റെ കാലാവധി എന്ന് പറയുന്നത് 15 years. ലെറ്റസ് ഈ 15 years നമ്മൾ കാണുന്ന കോസ്റ്റ് എന്ന് പറയുന്ന രണ്ട് തരം കോസ്റ്റ് ആണ്. അത് ഒരു കോസ്റ്റ് എന്ന് പറയുന്ന ഇനിഷ്യൽ ഇൻവെസ്റ്റ്മെന്റ്, ഇറ്റ് ഈസ് ദ ടിപ്പ് ഓഫ് ദി ഐസ്ബർഗ്. മുങ്ങിക്കിടക്കുന്ന സാധനം എന്ന് പറയുന്ന റിക്കറിംഗ് കോസ്റ്റ്, ഇറ്റ് ഈസ് എ പവർ കോസ്റ്റ്. ഒരു 15 years ഇത് രണ്ടും കൂടെ കൂട്ടുമ്പോഴത്തേക്ക് നമ്മൾ പറയും ലൈഫ് സൈക്കിൾ കോസ്റ്റ്. ഈ ലൈഫ് സൈക്കിൾ കോസ്റ്റ് കാൽക്കുലേറ്റ് ചെയ്യുമ്പോഴത്തേക്കാണ് നമ്മൾ എനർജി എഫിഷ്യൻസിയുടെ ഇമ്പോർട്ടൻസ് വരുന്നത്. ഒരു ഉദാഹരണത്തിന് മോട്ടോറിന്റെ കാര്യം എടുക്കുകയാണെങ്കിൽ, ഇന്ത്യ ഹാസ് ബാൻഡ് IE1 motor in 2017. Now we are talking about IE2 and IE3. Recently IE4 also has come. Now when you are starting a new industry, why can't you think of going for the IE3 or IE4 motor? അപ്പോൾ അതിന്റെ അത്രയും എനർജി എഫിഷ്യന്റ് ആയിട്ടൊരു സിസ്റ്റം വെച്ച് കഴിഞ്ഞാൽ നിങ്ങൾക്ക് പിന്നെ എനർജിയുടെ റിക്കറിംഗ് കോസ്റ്റ് കുറഞ്ഞിരിക്കും. ആൻഡ് യു നോട്ട് ഒരു എനർജി ഓഡിറ്റ് നടത്തി 3 കൊല്ലം കഴിയുമ്പോൾ വീണ്ടും മോട്ടോർ മാറ്റേണ്ട ഒരു സിറ്റുവേഷനിലേക്ക് വരുന്നില്ല. ഇത് മോട്ടോറിന്റെ കാര്യത്തിൽ മാത്രമല്ല, ഏത് കാര്യത്തിലായാലും നമ്മൾ എനർജി എഫിഷ്യന്റ് ആയിട്ടുള്ള സിസ്റ്റത്തിലേക്ക് പോകണം, റൈറ്റ് സൈസിങ്ങിലേക്ക് പോകണം. ഫോർ എക്സാമ്പിൾ, ഇഫ് യു നമ്മൾ പലപ്പോഴും ഈ പ്രസന്റേഷനകത്ത് എല്ലാ പ്രോസസ്സിനെ കുറിച്ചും എല്ലാ യൂട്ടിലിറ്റീസിനെ കുറിച്ചും, യൂട്ടിലിറ്റീസ് എന്ന് പറയുമ്പോൾ എയർ കംപ്രസർ, ബോയിലർ, വാക്വം സിസ്റ്റം, ഇതിനെക്കുറിച്ചോ, അല്ലെങ്കിൽ പ്രോസസ് എന്ന് പറയുമ്പോൾ അതിനകത്ത് വരുന്ന ഹീറ്റ് എക്സ്ചേഞ്ച് നെറ്റ്വർക്കിനെ കുറിച്ചോ, അല്ലെങ്കിൽ മൾട്ടിപ്പിൾ ഇഫക്ട് ഇവാപറേറ്ററിനെ കുറിച്ചോ, സ്പ്രേ ഡ്രയറിനെ കുറിച്ചോ, ഇതെല്ലാം നമുക്ക് ഇന്നത്തെ ഒരു സെഷനിൽ ഡിസ്കസ് ചെയ്യാനായിട്ട് സാധിക്കത്തില്ല. വി വിൽ ബി ഡിസ്കസിങ് ഓൺ ദി അപ്രോച്ച്, വി വിൽ ബി ഡിസ്കസിങ് വിത്ത് സർട്ടൻ കേസ് സ്റ്റഡീസ്. അപ്പോൾ ഇത് ഏത് യൂട്ടിലിറ്റീസ് ആയാലും ശരി, പ്രോസസ് എക്യുപ്മെന്റ് ആയാലും ശരി, യു ഹാവ് ടു ഗോ ആൻഡ് സെലക്ട് ദ മോസ്റ്റ് എഫിഷ്യന്റ് വൺ ആൻഡ് മോസ്റ്റ് ഓപ്റ്റിമംലി ഡിസൈൻഡ് വൺ എന്നുള്ള മെസ്സേജ് കൺവേ ചെയ്യുക വിത്ത് സം കേസ് സ്റ്റഡീസ് ഓൾസോ. ഇനി ഇതല്ലാതെ, ഇത് കൂടാതെ നമ്മൾ പലപ്പോഴും നെഗ്ലക്ട് ചെയ്യുന്ന ഒരു ഏരിയ ഉണ്ട്, എഫ്ലുവന്റ് ട്രീറ്റ്മെന്റ് പ്ലാന്റ്. എഫ്ലുവന്റ് ട്രീറ്റ്മെന്റ് പ്ലാന്റ് എന്ന് പറയുന്നത് അതിനകത്തും യു ക്യാൻ ഗോ ഫോർ എനർജി എഫിഷ്യൻസി. അപ്പോൾ അവിടെ ചെയ്യുമ്പോൾ ലെറ്റസ് ഫോർ എക്സാമ്പിൾ, ഇഫ് യു ഹാവ് എൻ അനറോബിക് ഡൈജസ്റ്റർ ബിഫോർ എൻ എയറോബിക് ഡൈജസ്റ്റർ, certainly നിങ്ങളുടെ പൊല്യൂഷൻ BOD COD ലോഡ് നിങ്ങൾ എനറോബിക്കിനകത്ത് കുറയ്ക്കാനായിട്ട് സാധിക്കും. അതനുസരിച്ച് നിങ്ങൾ എയറോബിക്കിനകത്ത് ഡൈജസ്റ്ററിനകത്ത് വരുന്ന ഇലക്ട്രിക്കൽ ലോഡ് ഫോർ ദ എയറേഷൻ വിൽ റെഡ്യൂസ്, യുവർ കെമിക്കൽ ഡോസിംഗ് റിക്വയർമെന്റ് വിൽ റെഡ്യൂസ്. അപ്പോൾ ഇതൊക്കെ കുറയ്ക്കാനായിട്ടും സാധിക്കും. അപ്പോൾ ഈ ആസ്പെക്ട്സിനെ മുൻനിർത്തിയാണ് നമ്മൾ പറയുന്നത്. ഇതെല്ലാം കൂടെ ഞാൻ കൺക്ലൂഡ് ചെയ്യുകയാണെന്നുണ്ടെങ്കിൽ എനിക്ക് പറയാനുള്ളത്, let us say if your total electric load comes to about 200 kilowatt of load, ഇത് ഒരു എനർജി എഫിഷ്യന്റ് ഡിസൈനിലേക്ക് പോവുകയാണെങ്കിൽ, HVAC ബിൽഡിംഗ് ആണെങ്കിൽ ഹീറ്റിംഗ്, വെന്റിലേഷൻ, എയർ കണ്ടീഷനിങ് സിസ്റ്റം ആയാലും ഹീറ്റ് പമ്പിന്റെ ആപ്ലിക്കേഷൻ വഴിയും പല ന്യൂ ടെക്നോളജീസ് വെച്ചിട്ട് ഒരു എനർജി എഫിഷ്യന്റ് സിസ്റ്റത്തിലേക്ക് പോവുകയാണെങ്കിൽ, perhaps you will be able to reduce your electrical connected load or demand of from 200 kilowatt to about 75 kilowatt. Let us say 75 kilowatt, this is achievable. അപ്പോൾ 75 കിലോവാട്ടിലേക്ക് റെഡ്യൂസ് ചെയ്യണമെന്നുണ്ടെങ്കിൽ ഇന്ന് കേരളത്തിന്റെ സാഹചര്യം അനുസരിച്ച്, where we are promoting in a large big way the solar photovoltaic system with the close coordination of ANERT and the Kerala State Electricity Board, the bundled utility in the state, നിങ്ങൾക്ക് ഇത് ഒരുപക്ഷെ 75 കിലോവാട്ടിലേക്ക് കുറയ്ക്കാൻ സാധിക്കുകയാണെന്നുണ്ടെങ്കിൽ നിങ്ങൾക്ക് സോളാർ ഫോട്ടോവോൾട്ടൈക് സിസ്റ്റത്തിലേക്ക് എൻറ്റയർ സിസ്റ്റം പവർ ചെയ്യാനായിട്ട് സാധിക്കും. ഗ്രിഡ് കണക്റ്റഡ് സിസ്റ്റമിന് നമ്മൾ വളരെയധികം പ്രോത്സാഹിപ്പിക്കുന്നുണ്ട്. ആ സാഹചര്യത്തിൽ ഒരു 200 കിലോവാട്ട് എന്ന് പറയുന്ന ലോഡ് 75 കിലോവാട്ടിലേക്ക് വരികയാണെന്നുണ്ടെങ്കിൽ നിങ്ങളുടെ പുതു സംരംഭം ഫുള്ളി സോളാറിലേക്ക് പവർ ചെയ്ത് ഓടിക്കാനായിട്ട് സാധിക്കുന്ന ഒരു സാഹചര്യവും വരും. അപ്പോൾ അതിന് നമ്മൾ സാധാരണ പറയുന്ന പോലെ VIP വെഹിക്കിളിന്റെ ഫ്രണ്ടില് പൈലറ്റ് വെഹിക്കിൾ പോകുന്നു എന്ന് പറയുന്നത് പോലെ, don't go for renewable solar at the first step, but you reduce your load by going for energy efficient design. ആ ഡിസൈനിലേക്ക് പോയി, ഓപ്റ്റിമൽ ഡിസൈനിലേക്ക് പോയി ലോഡ് റെഡ്യൂസ് ചെയ്തതിനു ശേഷം then you switch over from the conventional power to solar power. ഈ രീതിയിൽ നമുക്ക് പിന്നെ ഇത് മുന്നോട്ട് പോകാം എന്ന് ഉള്ള ആമുഖം ആയിട്ട് ഞാൻ പറഞ്ഞുകൊണ്ട് Dr. Nagesh Kumar, if he is ready, I will give to him. I think his computer has got some problem. If he is not ready, I think till the time I get a signal, maybe I have to go for some more time. See, friends, we have got empaneled the energy auditors. About 45-48 energy auditors are empaneled with us. Their contact details are available in our website. This program കഴിഞ്ഞതിന് ശേഷം, if you have any doubts, any services required, you can always contact our empaneled energy auditors. Around 60 to 70% are within the Kerala state, and about 35% are from outside the state also. അപ്പോൾ അവരെ കോൺടാക്ട് ചെയ്യാം, അവരുമായിട്ട് നിങ്ങൾക്ക് ഡിസ്കസ് ചെയ്യാം. അവരെ പല ആളുകളും ഈ പ്രോഗ്രാമിൽ പങ്കെടുക്കുന്നുണ്ടെന്നാണ് ഞങ്ങൾ വിശ്വസിക്കുന്നത്. അതല്ല, കൂടുതൽ എന്തെങ്കിലും വേണമെന്നുണ്ടെങ്കിൽ EMCക്ക് നിങ്ങൾക്ക് എഴുതാം. ഇനി ഈ പ്രോഗ്രാമിനെ കുറിച്ച് ഒന്ന് രണ്ട് കാര്യങ്ങൾ പറയാനുള്ളത്. Many of you are already started using the public chat box. Any doubt, any suggestion, please use the chat box. നിങ്ങളെ ചാറ്റ് ബോക്സ് നമ്മളെ EMC ഓഫീസേഴ്സ് വളരെ ഗൗരവപൂർവ്വമായിട്ട് ഇത് കാണുന്നുണ്ട്. നിങ്ങൾ കൊടുക്കുന്ന എന്ത് ക്വസ്റ്റ്യൻസ് ഉണ്ടെങ്കിലും, any questions you have, you raise it in the chat box immediately. Perhaps the speaker may not answer it at that time because he may continue with this presentation. But we will collect the answer from the speaker, and then we will make a FAQ document, and this PDF document will be shared to you. അപ്പോൾ അതുകൊണ്ട് ക്വസ്റ്റ്യൻ ചോദിക്കാനായിട്ട് ആരും മടിക്കണ്ട. നിങ്ങളുടെ ക്വസ്റ്റ്യൻസിന് എല്ലാ ക്വസ്റ്റ്യൻസിനുള്ള ഉത്തരം ഞങ്ങൾ ഒരു FAQ ഡോക്യുമെന്റ് ആക്കി, ഒരു PDF ഡോക്യുമെന്റ് ആക്കി നിങ്ങളുടെ ഡെസ്ക്ടോപ്പിനകത്ത് അവൈലബിൾ ആക്കി തരും. അതോടൊപ്പം ഇന്ന് ഈ വീഡിയോ പ്രസന്റേഷൻ കംപ്ലീറ്റ് ആയിട്ട് ഇറ്റ് വിൽ ബി അപ്ലോഡഡ് EMC യൂട്യൂബ് ചാനൽ. അപ്പോൾ ആ യൂട്യൂബ് ചാനലിൽ നിങ്ങൾക്ക് കാണാം. യു ക്യാൻ സബ്സ്ക്രൈബ് ടു അവർ യൂട്യൂബ് ചാനൽ, ആൻഡ് already 2 video presentations which we did earlier on 16th of May and 17th of May on energy efficient lighting and smart metering and advanced metering infrastructure that are available in our YouTube channel. You can download it. അതും നമുക്ക് ചെയ്തിട്ടുണ്ട്. പിന്നെ വേറെ ഒന്ന് പറയേണ്ടത്, I told you that we have already scheduled about 50 technical presentations in the next 10 months. 50 technical presentations already scheduled, and some more are in the pipeline. But I would request that if you have any suggestions on so and so topic to be discussed, let us say I want a suggestion on a spray dryer topic to be discussed, or a topic on multiple effect evaporator in a dairy industry to be discussed. Please come up with your suggestion. We will find the right person. If he is not available within the EMC, we will find out the right person from the energy efficiency fraternity, and then we will invite them to speak to you. ഈ പ്രോഗ്രാമിനകത്ത് കൺസൾട്ടൻസ് നിങ്ങളോട് സംസാരിക്കുന്നുണ്ടാകും. ഈ പ്രോഗ്രാമിനകത്ത് OEM എനർജി എഫിഷ്യന്റ് എക്യുപ്മെന്റ് മാനുഫാക്ചറേഴ്സിന്റെ ആൾക്കാർ സംസാരിക്കുന്നുണ്ട്. എനർജി കൺസർവേഷൻ ബിൽഡിംഗ് കോഡുമായിട്ട് ബന്ധപ്പെട്ട് ECBC മാസ്റ്റർ ട്രെയിനേഴ്സ് ആയിട്ട് BE എംപാനൽ ചെയ്തിട്ടുള്ള ആൾക്കാർ സംസാരിക്കുന്നുണ്ട്. നാഗേഷ് സാറ് വരുന്നത് വരെ എനിക്ക് സംസാരിക്കുന്നത് കൊണ്ടാണ് ഞാൻ ഈ കാര്യങ്ങളും കൂടി സൂചിപ്പിക്കുന്നത്. ഇനി അടുത്ത പ്രോഗ്രാം നമുക്ക് സ്റ്റാർട്ട് ചെയ്യുന്നത് 8ാം തീയതിയാണ്. 8ാം തീയതി സ്റ്റാർട്ട് ചെയ്യുന്ന പ്രോഗ്രാം എന്ന് പറയുന്നത്, there is a little difference between this program and the program which starts on 8th June. The 8th program is on ECBC. It is a 7-day program, each day having 1.5 hour session, and it is a certificate course in fact. And first day it is available for public, in the sense anybody interested in ECBC or energy conservation building, you are invited to join. But second day onwards, it is restricted to 30 numbers of participants, because we are having a hands-on energy simulation training program. So the computer should be available, the software should be downloaded in the computer, and these people have to go through a live simulation exercise, and that will be evaluated by the ECBC cell functioning in the EMC, and the result will be sent to them, and with comments on what need to be improved from their side. So it is a hands-on training program. Therefore, we are limiting the numbers to 30 for the ECBC program, which starts on 8th of June. and we have already scheduled, I think, 6 or 8 numbers of such sessions of 7 days of duration. And so it happens on second week of every month. This ECBC hands-on training through energy simulation will happen on the second week of every month starting June. Also, we have another program we have scheduled is which happens on all Wednesdays. That is, in fact, a webinar come phone-in program. It is a live phone-in program come webinar from 11 to 12 June, 1 hour on all Wednesdays, where we will speak on domestic energy conservation, and people will be invited to ask their doubts when they construct a house, when if they want to reduce the electricity bill, what they need to do in air conditioners, refrigerators, lighting, if they have a doubt on their washing machine or their television or electric cooker, ആ ഡൗട്ടുകളും നമുക്ക് ഇതിനകത്ത് റെക്ടിഫൈ ചെയ്യാനായിട്ട് സാധിക്കും. So every Wednesday we will meet our energy stakeholders, particularly from the domestic sector, for about 1 hour for a live phone-in plus webinar session. Those who do not have access to internet or webinar or a computer or this type of platform, if they are not able to access, നമുക്ക് അവർക്ക് ഫോണിൽ കൂടി വരാനായിട്ട് സാധിക്കും. And they need not pay the phone bill, we will pay the phone bill. And we have a toll-free number for that. We will pay the phone bill also. They can ask the question. So അതാണ് വേറൊരു program. And another program what we have exclusively for the agricultural sector, agricultural pumping sector. ഇന്ന് കേരളത്തിൽ നമ്മൾ പലർക്കും അറിയാം, നമ്മൾ പച്ചക്കറികൾ വെളിയിൽ നിന്നാണ് കൊണ്ടുവന്നുകൊണ്ടിരുന്നത്. ഇന്ന് കോവിഡ് നമുക്കൊരു ഇൻഡിക്കേഷൻ തന്നതിന്റെ അടിസ്ഥാനത്തിൽ ഗവൺമെന്റ് തന്നെ പച്ചക്കറി കൃഷി വളരെയധികം പ്രോത്സാഹിപ്പിക്കുകയാണ്. തരിശു നിലത്തിൽ കൃഷി ഇറക്കുന്നത് പഞ്ചായത്തും മുനിസിപ്പാലിറ്റിയും കോർപ്പറേഷൻസും പല സന്നദ്ധ സംഘടനകളും വ്യക്തികളും മുന്നോട്ട് വന്നിരിക്കുകയാണ്. ആ സാഹചര്യത്തിൽ ഏത് തരം പമ്പ് വയ്ക്കണം, സബ്മേഴ്സിബിൾ പമ്പ് വയ്ക്കണോ, അതിന്റെ ഗുണഗണങ്ങൾ എന്താണ്, അതിന്റെ സക്ഷൻ ലൈനും ഡെലിവറി ലൈനിലും നമ്മൾ ശ്രദ്ധിക്കേണ്ട കാര്യങ്ങൾ എന്താണ്, ഇങ്ങനെയൊക്കെ സംബന്ധിച്ച് മലയാളത്തിൽ ഈ ഡൊമസ്റ്റിക് കൺസർവേഷൻ പ്രോഗ്രാമും അഗ്രികൾച്ചറുമായിട്ട് പ്രോഗ്രാമും മലയാളത്തിലായിരിക്കും. ആ പ്രോഗ്രാം നമുക്ക് എല്ലാ തേഴ്സ്ഡേ, ലാസ്റ്റ് തേഴ്സ്ഡേ ഓഫ് ദി മന്ത് വി ആർ ഹാവിംഗ് അബൌട്ട് 1.5 hour സെഷൻ ഓൺ ലാസ്റ്റ് തേഴ്സ്ഡേ ഓഫ് ദി മന്ത്. ആ പ്രോഗ്രാമും മലയാളത്തിലായിരിക്കും. ജൂണിൽ ആ പ്രോഗ്രാം സ്റ്റാർട്ട് ചെയ്യുന്നുണ്ട്. ഇനി 10 മാസം അതുണ്ടാവും. അതിനകത്തും നിങ്ങൾക്ക് ജോയിൻ ചെയ്യാം. ഞാൻ നമ്മുടെ ടോൾ ഫ്രീ നമ്പർ ഒന്ന് പറയാം, ഒന്ന് നോട്ട് ചെയ്യാൻ പറ്റുകയാണെങ്കിൽ നോട്ട് ചെയ്യുക. അതുപോലെ പബ്ലിക് ചാറ്റിനകത്തും ഐ വിൽ ആസ്ക് അവർ കൊളീഗ്സ് ടു റൈറ്റ് ദ ടോൾ ഫ്രീ നമ്പർ. നമ്മുടെ ടോൾ ഫ്രീ നമ്പർ എന്ന് പറയുന്നത് 1800 425 1800 425 5256 ഇതാണ് നമ്മുടെ ടോൾ ഫ്രീ നമ്പർ. ഈ ടോൾ ഫ്രീ നമ്പറിലാണ് നിങ്ങൾക്ക് വിളിച്ചു കഴിഞ്ഞാൽ നിങ്ങളുടെ ഫോണിൻ പരിപാടി, ബുധനാഴ്ച പരിപാടി അറ്റൻഡ് ചെയ്യാം. ഈ കാര്യങ്ങൾ ദയവ് ചെയ്ത് നമ്മളുടെ കൊളീഗ്സിനോടും ഫ്രണ്ട്സിനോടും കൂടി ഒന്ന് സർക്കുലേറ്റ് ചെയ്യണം. നിങ്ങളെല്ലാവരും ഈ ഇതിനകത്ത് ജോയിൻ ചെയ്ത ഏതാണ്ട് വി ഹാവ് റിസീവ്ഡ് അബൌട്ട് 100+ രജിസ്ട്രേഷൻ. നൗ വി ഹാവ് ഹാവിംഗ് ഓൾറെഡി 72 യൂസേഴ്സ് സൈൻഡ് ഇൻ ദിസ് വെബിനാർ. നിങ്ങളെ പെർമിഷനോടുകൂടി ഒരു EMCയുടെ എനർജി മാനേജ്മെന്റ് ഇൻസ്റ്റിറ്റ്യൂട്ടിന്റെ അലുമിനി നെറ്റ്വർക്കിലേക്ക് ഞങ്ങൾ ഇൻവൈറ്റ് ചെയ്ത് ചേർക്കുകയാണ്. ആ അലുമിനി നെറ്റ്വർക്കിലേക്ക് വന്നു കഴിഞ്ഞാൽ ഞങ്ങൾ നടത്തുന്ന എല്ലാ പ്രോഗ്രാംസിന്റെയും ഇൻവിറ്റേഷൻ നിങ്ങൾക്ക് ഇൻവേരിയബിളി യു വിൽ ഗെറ്റ് ദാറ്റ്. യു വിൽ ബി ഇൻ അവർ മെയിലിംഗ് ലിസ്റ്റ്. നമ്മുടെ പ്രസന്റേഷൻ സ്ലൈഡും അതിന്റെ വീഡിയോയും മറ്റും നിങ്ങൾക്ക് അവൈലബിൾ ആയിരിക്കും. സർട്ടിഫിക്കറ്റ് കോഴ്സുകൾ ഞങ്ങൾ 6 എണ്ണം പ്ലാൻ ചെയ്യുന്നുണ്ട്. ഈവൻ സ്റ്റാർട്ടിംഗ് ഫ്രം സ്കൂൾ ഗോയിങ് സ്റ്റുഡൻസ് ടു എനർജി കൺസർവേഷൻ ബിൽഡിംഗ് പ്രൊഫഷണൽസ്. അപ്പോൾ സർട്ടിഫിക്കറ്റ് കോഴ്സ് ഇന്നലെ ഞങ്ങൾ എക്സിക്യൂട്ടീവ് കമ്മിറ്റി ആയിരുന്നു, കമ്മിറ്റി അപ്രൂവ് ചെയ്തിട്ടുണ്ട്. 6 പ്രോഗ്രാം ആയിരിക്കും. അതിന്റെ കൂടെ നമുക്ക് ഓപ്പറേറ്റേഴ്സ് ആൻഡ് ടെക്നീഷ്യൻസ് ഓഫ് ഇൻഡസ്ട്രി, പർട്ടിക്കുലർലി വി ആർ എയിമിംഗ് ഫോർ ദ PSU, അവർക്കും കൂടി വേണ്ടി മലയാളത്തില് എനർജി എഫിഷ്യൻസി ഒരു ഷോപ്പ് ഫ്ലോർ ലെവൽ എങ്ങനെ ആയിരിക്കണം എന്നുള്ള ഒരു പരിപാടിയും നമ്മൾ പ്ലാൻ ചെയ്തിട്ടുണ്ട്. അപ്പൊ ഈ പ്രോഗ്രാം എല്ലാം ഈ നിങ്ങൾക്ക് അറിവിലേക്ക് ഷെയർ ചെയ്യുന്നു. നിങ്ങൾക്ക് ഇത് പാർട്ടിസിപ്പേറ്റ് ചെയ്യാം. അതുകൊണ്ട് നിങ്ങൾ ദയവ് ചെയ്ത് ഇത് ആസ് അവർ അംബാസഡേഴ്സ് ഓഫ് എനർജി എഫിഷ്യൻസി, ഐ വുഡ് റിക്വസ്റ്റ് ഓൾ ഓഫ് യു ഹു ആർ പ്രസന്റ് ഹിയർ, who are participating in this program, to broadcast among your contact list and among your associates and students, teachers, any person in this who is using energy, definitely they will have something to hear, something to learn from our Energy Management Center webinar program. Kerala specific program, but the speakers national and internationally level reputed speakers in there will be a feedback feedback form feedback form that will be learning for us on how to improve our people for the next program program improvement from the feedback form they will get the input. Our Mr. Nagesh Kumar, who is based in Chennai, he will come join within another 3 minutes. So please bear with us. In the day, chat box I will just like to introduce Energy Management Center. We have established as an autonomous center under Department of Power, Government of Kerala in 1996. Way back the BE has come up. At that time when we started, there was an energy management center based in New Delhi. Our model Energy Management Center Kerala in 1996 we started our operations in 1997 to be precise, and in the initial days we have been more advocating on promoting on energy efficiency and conservation. Kerala the unique factor is that about more than 50% of our grid power goes to the domestic sector, goes to our houses, and another 12, 13, 14% goes to the buildings, in the sense of hospitals, hotels, IT firms, etc., etc. So about more than 60% goes to the building. So we have a dedicated program for a building sector. Industry-wise, we are a bit, we don't have much large energy-intensive industries. We have one cement plant, we have one refinery, we have one fertilizer. We don't have an iron and steel plant. We have 2 titanium dioxide plants. Industry-wise, more of micro, small, and medium enterprises. So we have certain programs devoted for MSMEs, in the sense we have done some demonstration projects bringing IT solutions to MSME, even like the rugged brick and tile industry way back in 1997. And when the Energy Conservation Act was passed in the Indian Parliament in 2001, and the Bureau of Energy Efficiency was started as a statutory body for implementing the EC Act provisions all over the country. Accordingly, the EMC has been designated as the state designated agency, SDA, in Kerala for implementing the provisions of Energy Conservation Act 2001. And we also host a UNIDO Regional Center for Small Hydropower, and we have a ECBC cell, we have an SHP cell in our organization, and we are now situated in near the CET, College of Engineering, Trivandrum. We have a 40,000 square feet gold LEED rated building, and we are an energy positive, in the sense we get our power from solar, and we pump to the grid also, the excess power. There is a question that will there be a certificate issued for this webinar? Yes, definitely. If you want a participation certificate, you can send an email to us. Definitely, we will issue a certificate. And for the other certificate courses, what I mentioned, like for example, for the ECBC training program, the participants have to write a small brief examination. It could be in the form of a quiz, or it could be in the form of a exercise where you have to do the simulation and send it back. For those certification program, there will be an evaluation, a very interesting evaluation, I would say. But for all other webinars, yes, definitely we will give you a participation certificate. EMC is doing all these programs in the classroom mode for the last 20 years, and now because of this present situation, we are moving towards this webinar mode. About Adana, minute Nagesh sir Maruna Pradikshik. Is there any bioenergy power station in Kerala? We don't have a bioenergy power station in Kerala, but we have got a lot of biogas plants. Kerala, the biogas plants is that the unique feature is that instead of using cow dung, normally which is happening in the northern part of the country, our biogas plant, the feedstock is kitchen waste. So with using kitchen waste, we are generating biogas. In my house also, I am using a biogas plant of 1 meter cube capacity for the last I think 15, 16 years. It is no problem. And that 1 meter cube biogas plant will give me a saving of about 60% in my LPG consumption. And as you know, 60% of the biogas is methane, rest is carbon dioxide, H2S, moisture, and carbon dioxide, etc. Whether ECBC program starting from 8th has been filled. We already have got registration for about 85 participants. So on 8th, there is no problem. Any number of participants you can join. But on 9th onwards, as I earlier told, 9th, 10th, 11th, 12th, that 6 days, we will be restricting to 30. But please, sir, you can register. Definitely, we will give the seat for the next week. In the next month, second week. All the coming 8 months, second week, we have devoted our webinar for ECBC. Therefore, you can register. We will give you the seat in the next month, second week. We will try. Could you give more insightful into how you power your office? Yes, we have got about, I think, 30-40 kilowatt of solar photovoltaic system. It is a grid connected system. The Kerala State Electricity Board is very generous in terms of giving grid connectivity. So what we need, our load is also very reduced in the sense we are using all. We are a full LED office. We are using the VRF system for our 250 capacity auditorium, which of course now it is not being used post COVID, and so our energy, the load has, from the, as I told you, from the design stage, since we have thought of this, our load is very reduced, and therefore we generate the power from solar, and when Saturdays and Sundays we are not working, the solar is pumped to the electricity grid, and we get money from KSEB also every September. Yearly on September, they reconcile how much we have taken from KSEB, how much we have given to KSEB, and the net will be paid. If it is due to us, it will be paid back to us. So that is about our solar system. We would like to go for a small wind also to make it a hybrid, but unfortunately we are yet to find out a good vendor for small wind turbine. If you know somebody, please connect to us. Is those biogas is domestic or for electrification? Biogas plants in Kerala is mostly for thermal route. That means it is for cooking purpose. For they are using, even if you go for institutions where you have 30 meter cube, 70 meter cube, 120 meter cube, large RCC constructed biogas digesters, they use it for cooking. And but there are systems installed in our slaughterhouses and in our community, what you call market, where this biogas is being used as a fuel for powering the DG set or the gas engines. Earlier it was about 70% biogas, 30% diesel. Now we have got full biogas powered, 100% biogas powered DG set, but that is very, very limited. In the sense, hardly a couple of maybe less than 5 for electrification. But mostly it is for thermal application. I have one in my home since 20 years. It's working. My question is about the electricity production from biogas. Electricity production is of course possible, but it is not compared to the electricity cost, because it is very subsidized. You know, we are getting from the utility. So compared to the electricity cost, if you go for a biogas route, it is little bit not cost effective, and we need to purify this biogas. We have to take H2S out. We have to take out the moisture, then feed it to the gas engine. So people have not gone much into the electricity generation route. Will smart metering system be implemented in Kerala? We hope so, but there are a lot of challenges, and KSEB is on the work, and as a part of your central government JNNURM scheme and all, we have got some pilot work which we are planning in the Cochin Corporation, which is Cochin is the business capital of Kerala, which is the most energy efficient technique till now. That all these things we will be discussing. I think Mr. Nagesh is on line. Let me invite Dr. Nagesh Kumar. He is a long time colleague of EMC. While working in National Productivity Council, he has got many, maybe I think more than 30 years of experience in energy efficiency field in the country and outside. And he is I would say, is a good orator in terms of energy efficiency capacity building program. So warm welcome to Dr. Nagesh. And please, thank you very much.
Presenter കുറച്ച് delay ആവുന്നുണ്ട് അവിടെ. Please hold on. Until then, maybe we can discuss about this. Someone, Mr. Jose Dominic has asked for, and I expect an assistance from government side to help set up a biogas plant. Actually, the biogas plant as such government set subsidy programs ഒന്നും ഇല്ല. പക്ഷെ അനേർട്ടിനോട് കോണ്ടാക്ട് ചെയ്യാണെന്നുണ്ടെങ്കിൽ അവരുടെ ഏതെങ്കിലും ഒരു ആക്ടിവിറ്റിക്കുള്ളിൽ കൂടി കൊണ്ടുവരാൻ പറ്റുമെന്ന് ശ്രമിക്കാവുന്നതാണ്. For more questions, can I send a personal email to you? Is it okay for that? Yes, very good. No problem. You can either you can ask directly in this chat box, or you can also send your messages across in email. No problem. Okay, the certificate of the last webinar is getting ready. I think it will be sent to you very soon. Sure. Now, Dr. Nagesh has arrived. Let me hand over the mic to you. Thank you.
Right. Okay. So, good morning to all of you. And this is a short talk on energy efficiency from the design stage. So when you want to put up some industry, or you want to become an entrepreneur and start some service or manufacturing operations, how we should go about and incorporate energy efficiency and sustainable development in the initial stage itself. So that will be the objective of the talk today. And so here, as we see, the first thing is choosing the right product. So what is that you want to produce? What is that you want to make a business of? So these are the basic questions that we ask. Is there a real need for the product or service in today's market? So sustainable development itself questions the need for certain products. So we don't need to use certain products which are not really of any functional value. So identify a product which will be of some functional value, some utility or some use to the consumer. And is your new product or service better than anything else currently available? So currently there are several products which are similar in nature. Now we have to create something which is new to the product so that you can sell better, or the service you're going to render should be better than what is available. So from that aspect, this question is applicable. And what are the 3 ways that your product is superior to your competition? So you have to identify at least 3 points which will make your product superior to the other competitive products in the market. And is your product lower priced or of better quality than anything else that is available? Then the other thing, when you talk of competitiveness, ultimately it comes to the price. The quality being equal or even better, the price is an important factor which will be considered. So our objective in any of these initiatives that we are going to start as an entrepreneur will be to minimize the production cost as much as possible. So we look at some of the possibilities in this session, how to minimize the production cost, and then how is the product or service to be manufactured or produced. So what is the production process? This is another important step. So when you want to produce a product, there are infinite ways of doing it. What is the best possible way which will use minimum resources, produce minimum waste, and consume minimum energy, as a result of which the product cost will be minimum. So the manufacturing process needs to be pinned down, and so we'll also focus on some of the examples here. And most important thing is the product innovative? So innovation is a key, as we know that any product which is different from others has got a good value in the market, easily saleable. So the innovative component of the product design has to be taken into account. And when you set up an industry, these are the inputs that are required. So you have raw material that is required for making some product. We need labor to do the job, and we need capital. Money is required to purchase things and make things operational. We have to find the market for the product. Then we need to transport the product. One is the transportation of the products, and then the transportation of the raw materials. Then we need land, and of course, most importantly, we need power or energy that is required to make modifications in the product or any changes in the product, in the raw material, so that product is produced. So these are the various inputs, and of these various inputs, what is that we can reduce, where we can reduce easily. So if you see this picture, raw material, can we reduce the raw material to the product? It's very difficult. Once you have fixed up production process, so what we are going to do is to produce something with minimum wastage. So already we have decided on a manufacturing route with raw material getting converted into product with minimum wastage. So reduction in raw material becomes very difficult. Labor. So if you see labor, minimum amount of labor is required for doing work, and you cannot minimize the labor costs. So there's the minimum wages that need to be paid to engage the labor. So labor costs, of course, now no longer considered cheap. Labor also a significant cost. Then the other costs will remain there. But one thing what you can see here is the power or the energy costs. So the energy cost is something where a lot of potential exists. So this is where we are going to focus, how to reduce the energy costs, because in any manufacturing activity there are a lot of energy wastages that are taking place. Many of these things happen by poor choice of equipment or gadgets in the design stage itself. So in the design stage, if the selection is proper, then your energy efficiency to a great extent is guaranteed. Then in the operations, if any energy wastages are there, that can be rectified by using some retrofits or simple modifications. But the most important thing is to have a design stage energy efficiency incorporated into all the process equipment. Simple example is, suppose we are building a shed, and if you have closed the shed from all sides, daylighting is not coming into the shed, which means you have to use artificial lamps, our whatever tube lights or the LED lamp, whatever we need to use it inside the shed or the factory. So instead, in the design stage itself, if you incorporate the design for allowing natural light, then you don't need to use artificial lamps for lighting up the shed. So this is one example. Like this, we have several examples where at the design stage itself, if you take care, phenomenal amount of energy can be saved, and which will lead to cost reductions for the company. Now, when we talk of the product, we are looking at a component called the design for environment. So this is a thing which is very popular in the European countries, DFE, it is called design for environment. So while producing the product or while designing the product, how best it can be designed so that it is after the final usage, it is not dumped into the wastage. So there is a circulation which takes place. Whatever is the waste, it is recycled back. Again, products are produced. So there is nothing called ultimate discharge into the environment or a pollution to the environment. So if you look at this, for example, so the conventional thinking is you take raw resources from the earth, then make them, use them, finally dispose them. So we have huge piles of garbage, waste material which are getting disposed into the environment every day. Either it goes into the land or the sea or the rivers. So this is a linear approach. That means you take raw materials, convert them into products, use them, throw them. So no longer it is going to be used. This is a linear process. When you look at the product, you have to look at what is known as a circular design or the circular economy. The circular economy, you take the raw materials, you make some product and recycle them. So make, use, reuse, remake, recycle. Again, make, use, reuse, remake, recycle. So that means the resources are continuously put to use. There is no dumping into the environment. So this is something which you have to keep in mind when you are, especially when you are going in for some new products or even a product which you are going to make, which is already available in the market. You look at this concept, what kind of raw materials we are going to use, what is the production process we are going to use, how the environmental aspect can be taken care of, both in the disposal stage as well as in the manufacturing stage. So this is the key. And if you look at some of the typical examples, so this is the manufacturing of jeans. So they say one t-shirt and one jeans, one pair of jeans, for producing this, something wrong about a society that uses 7,500 liters of water to manufacture this. The amount drunk by a person in 7 years to manufacture a pair of jeans. So this is a highly resource intensive process. Somebody has thought about this jeans or the t-shirt and the manufacturing process has been thought out, but the resource intensity of these operations are not considered. So today we are, whatever the products we are using, most of the products are highly energy intensive, raw material intensive, resource intensive, and of course in this processes a lot of chemicals are also being used, which are ultimately finding their way into the rivers and seas, and you're contaminating the land mass. So this is one important thing that at least in future, for the interest of the future generation, the interest of sustainable development, when we look at a product, we look at the product not only from the saleability but also from this environmental sustainability. So this is now what is called popularly called the circular economy. The circular economy takes into account that all the raw materials will be completely utilized back even after the disposal of the product. So there's a continuous recirculation of the resource. And this is another terminology which is the new eco-design. The product itself is designed in such a way that it consumes least amount of raw materials, it produces high quality products, and it uses a more efficient production process. In the production process, it uses least amount of energy, produces least amount of effluents or emissions, and also uses least amount of water and other resources. So fewer emissions are there and more sustainable. That means that there will be a continuous availability of all the resources because you're conserving the resources. Say for example, water, if you're saving on water and using minimum amount of water, the water availability is going to be there throughout the year. So it is going to make industries more sustainable. Consumers are going to be more happy. So this will be the selling point in the years to come. Sustainable. How sustainable is a product? So in the manufacture of the product or the design of the product, how sustainable the product is, whether it has gone through a process which has been highly pollution intensive or resource intensive or energy intensive, and how we can dispose the product, whether it is environmentally friendly. These are all the factors which will be considered by the consumers of the future. So all this makes the differentiation in the market, especially the happy consumer when he looks at the product from the sustainability point of view. This is the practice in vogue in Europe and many other developed countries. People, when they buy a product, they are even prepared to pay a higher price if they know that the product has been produced in a sustainable way. So these are all the factors which you should consider as a new entrepreneur. These things will have a big market in the years to come. So in the manufacture of any product, we have, these are the components as we had already discussed: raw materials, labor, maintenance, energy of course, and other inputs. So these are the most significant inputs. So as you said, raw materials, not much can be saved in terms of cost. Labor, definitely not. Maintenance cost, some amount of maintenance will be involved, and we need to maintain the equipment and the factory, so this amount also will be involved. But energy, as we said, the efficiencies of the equipment, if you see, ranges dramatically from as low as 1% to 60%. So there is a lot of scope for saving energy, and this will be best done during the initial design stage of the factory itself. Now, the first step that you need to do when you want to make your factory energy efficient is first look at the tariffs. So you want to make the energy costs as low as possible. So what is the most appropriate tariff which if I use will make my energy cost the least? So if you look at the KSCB tariffs, there are different tariffs. So you can be classified as a low tension consumer or a high tension consumer, LT consumer. If you're an LT consumer, directly the power will be provided from the lines of the KSCB. You don't need a transformer. In the HT consumer, there will be a transformer and the voltage will be given at 11 kilovolts and then it will be stepped down to 440. So these are the very different categories depending on what is the intensity of power you are going to draw or use. So in this case, for example, if you see this, there's something called a connected load. If you add up all the motor loads in your factory, let's say if it is connected load of and below 10 kilowatt, less than 10 kilowatt, you have to pay a fixed cost of 120 rupees per month. And if it is between 10 kilowatt and 20 kilowatt, you have to pay 75 rupees. Connected load above 20 kilowatt, rupees per kVA. So 170 per kVA like this you have to pay. So these are the tariffs, what are called fixed costs. They don't vary with the amount of energy that you use. Then there's another cost called the energy charges, where the charges will apply as and when you use the energy, how much energy you have used multiplied by this cost. So roughly it's about 5 rupees 65 paise per unit. So this is one category, LT4A industry. Like this, there are different categories. This is LT4B for the IT and IT enabled services. So here it goes through a different tariff. Similarly, you have for agriculture, there's a different tariff. A fixed charge is levied, rupees 10 per kilowatt. And energy charges are, of course, agriculture is subsidized. 2 rupees 30 paise is the energy charges. Now, the next important thing is the consumption area. So we have the tariff has been decided. We have fixed the clause. What is the tariff clause we are going to be using? Then coming to the equipment point of view, what are the possibilities? Where all we can possibly bring about optimization of energy or saving of energy? And so for this, you have to look at your installations in a broader way. For example, in this slide, what you are looking at is a simple printing press. So this is a printing press. This entire room is air conditioned. There's a 8-color printing machine which is there in this room. And there's an air conditioner here. What you see is an air conditioner here. And you see all the lamps here, air conditioner. The entire room is air conditioned. Now, if we use an air conditioner, it's one of the most expensive equipments to use. We also use it in our houses. So 1 ton of AC, 1 ton AC, if you are using it for 1 hour, you may be consuming nearly 2 units of energy. That means it works out almost in the industrial tariff, what we have seen, it works out almost 13 rupees per hour you'll be spending when you operate an air conditioner. Now here, that means you have to have a simulation. What will happen when we start the printing press, when the air conditioner is required, and why the air conditioner is required. So you have to question every equipment. Now, if you see, in this case, it was not the perfect design. Yeah, just 1 second. Yeah, if you see this, now this is the air conditioner, close-up view of the air conditioner, what we are seeing. Now, when what happens in a printing press, when there is one run, suppose some product is produced, when they change the product, there is almost about 10 hours gap, changing the rolls, changing the screens. So many other cleaning processes take place. So there is a gap of 10 hours. So suppose there is almost 10 hours of production process, there is a 10 hours gap in which the rolls are changed, the screens are changed, and cleaning is taking place. Now if you see, we need to question, do we also need to run the air conditioner when there is no production, when only cleaning is taking place, or when roll changing is taking place? Do we need to run the air conditioner? So in this process, the printing press was doing that. And so it was not the right practice for because there is no need for air conditioning during the changeover period. So what was done was we cut open the wall, provided an exhaust fan. So once the production process is over, the air conditioner will be stopped and this exhaust fan will operate. So the exhaust fan is about 50 watts. Air conditioner is about 1200 watts. So you can see the difference. So here the objective of providing exhaust is to exhaust the fume. Printing produces a lot of fumes. The fumes have to be exhausted. So for this, the fan was provided. The air conditioner will be stopped and the fan will operate once the production is over. This is something which possibly in this case we had this provision. This opening was there and we were able to cut open this and provide a fan. So it's a case of retrofit. But in many cases you can do this right at the design stage itself, which will avoid a lot of complications. Many times for retrofit you may not have space. It will be very difficult to accommodate something in this case. And so what we are looking for is, why this AC? First of all, why AC? I mean, you have to question each and every application. Why AC at all? Is there a requirement? Then they said all the bearings, the machine itself is from Germany and it needs to operate at 25 degrees. So then the AC is must. is the air conditioner the most energy efficient one? So what are the air conditioners available in the market? What is their energy efficiency? So today, these days, you have star labeled appliances. The Bureau of Energy Efficiency in Government of India has come out with a star labeled equipment by which you can select the most energy efficient air conditioner. So first thing is eliminate if possible. If I don't need an AC, I completely save energy, I completely save on the initial capital cost. Then the next step is, if you must provide an AC, then we need to go in for the most energy efficient one. It may be 20% costlier, but when you look at the initial cost, it is only a marginal cost. 20% additionally you are going to provide, and that 20% is going to get paid back in less than 6 months with the energy that you're going to save. So we have now today we have 5-star labeled air conditioners which are quite energy efficient. We also have inverter based ACs where the energy efficiency is much higher than the conventional ACs. So you have to look into the design stage energy efficiency, and then again, then the question is how often this AC is going to be run. Whether it is going to run for 24 hours, what is the need? Then this thing should occur in the beginning itself, that there is going to be a 10-hour production, a 10-hour changeover. So 10-hour changeover, whether it is required. If it is not required, what are the alternatives? So then in the design stage itself, this kind of fan arrangement could have been provisioned. Beyond this, what you need to think of, what are the temperatures during the daytime and the night time in this city? So typically nighttime temperatures are very low, and even in warm climates, you will find that nighttime temperatures touch 25 degrees even for about 3 to 4 months, let's say. So the 3 to 4 months, can we avoid this air conditioner and put a blower? So it only blows air inside. Outside air is already 25 degrees. You blow cold air from outside ambient and then exhaust it continuously. So that is called once through cooling or the free cooling. You don't need to run the air conditioner. Take the outside air and blow it inside the room, exhaust it. So this makes the environment also clean, and also we are making use of the low temperatures available during the night time, or in the winter season when there is a daytime temperature itself is around 25 degrees, you can use that. So that means ideally in the design stage, this air conditioner should have been the most energy efficient. Maybe we could have gone in for an inverter based air conditioner. Then we would have had a blower here which would blow the air once the temperature. You can have a sensor also, ambient air sensor. You measure the temperature of the outside air, ambient air. If it is less than 25, it cuts off the AC and starts a blower here. The blower will blow the air from ambient inside the room, and the exhaust will start and take away the air from inside. So these are all the things that you can consider during the design stage. Of course, each factory will have unique applications, but conceptually, the approach to design stage efficiency is very similar. As we said, it's only the questioning why it is required. If at all it is required, are we going in for the most energy efficient equipment? Then what is going to be the operations? Is it going to be 24 hours continuous or on and off? During off time, what happens? So when you keep on questioning, then automatically you get the ideas and you arrive at the most efficient design. So in the same company, it's a printing press, of course, and if you see, the paper rolls are coming for printing, the cartons. They make cartons for the various products, and these cartons are coming from paper mills, and these paper mills send them to this wood packing. The cartons rolls are packed in wood, and so this packing is removed, and then the carton is taken for the production. Now, what do they do with this waste wood, packing wood? So if you sell it to a fellow who is taking away all this waste, he may be giving probably say 50 paise per kilo or something like that. Or sometimes you have to pay for removing this if there is no need in that area. Instead, this printing press had about 300 employees, and there was a canteen. So the canteen wanted a boiler. They had a boiler using diesel. Now, instead of using diesel, it was suggested to use this waste wood. So they converted the boiler and they started using this waste wood. One is the disposal has become simple. They don't have any disposal problem. And at the same time, there is also a saving in fuel. So diesel savings was enormous in this case. So this is also something which was retrofitted, but again can be considered in the design stage itself. The design stage itself, if you had considered, then you need not have purchased a diesel-fired boiler. Of course, that acts as a standby now, but in the design stage itself, we could have constructed a wood-fired boiler. And coming to some of the machines that you will be using, say for example CNC machines or presses or any other machine tool, it uses a lot of oil as well as coolants. So it takes away the heat from the machines. So the machine will be there and some work will be performed, heat will be generated, and the heat is removed by circulating oil or lubricant. So these oils will have to be cooled. Again, there will be a hydraulic power pack in some of the presses and other equipments. We'll have hydraulic power packs where hydraulic oil will be circulating inside the machines. So all the heat will be removed from the machines and taken out, which again has to be further dissipated to the environment. And for this, what the machine manufacturers normally do is they supply a package chiller. This is a package chiller, what you see here. This chiller, like our refrigerator, so it takes that hot circulating oil or the coolant, cools it and sends it back to the machine. Now when you use chiller, you can of course cool this oil or the coolant, but the simpler way is to use cooling water. Whatever water is available in ambient temperature is about 30 degrees. So you can use that water for cooling these lubricants or coolants, and because chiller is very expensive. You have this compressor, typical air conditioning components, whatever is there in this also. So the chiller is 10 times more expensive than cooling water. So wherever possible, use cooling water to remove the heat and don't use a chiller inside the plant. Other important things which matter is also looking again, it's basically most of these, what we are trying to say is based on common sense and also some amount of lateral thinking. If you see, this is a furnace, underground furnace. So this is a lid, and whatever treatment, this is annealing. Annealing means some kind of a heat treatment is done to some products. So this product will be put in this basket. This is a basket. These products will be transferred to this basket. This basket will be lowered inside the furnace. This lid will be opened, and this entire basket containing the materials will be lowered inside the furnace. Lid will be closed, and then it will get about 800 degrees centigrade, where annealing takes place. Metallurgical properties change. So this is an electric furnace. Electricity is used for this. If you want to heat up this materials inside the basket, you also have to heat this. So heating also takes place for this basket. And if you measure what is the weight of the products, it is only 70 kgs what is going to the basket. But the basket itself is weighing 60 kgs. So almost an equal amount of weight is there in the basket. So that also consumes energy. You have to heat that also to 800 degrees centigrade and then cool it. So resulting in a lot of energy wastage. So in the design stage itself, the first thing that you should ask for is, how do I do this operation, annealing? Is this the only way of doing it? What will be my energy cost if I do this? Because I'm going to use electricity. So if I use electricity, what are the advantages? What is the energy cost? Suppose instead of this I use oil, diesel or LPG or some other oil, what will be my energy cost? What are my advantages? So this has to be thought about before even purchasing the furnace. Then let's say we have purchased this furnace. Then where all my energy will be going? My energy will be going for heating up the product as well as this basket. Product, we cannot do much about this. 70 kgs means, yeah, it will be there. The weight of the product will be there. But basket, can we reduce the thickness of this material? So from 60 kgs, can we bring it down to 40 kgs or 30 kgs? So here there is nothing, no functional value for the basket. It is only to hold this material which needs to be annealed. Now this weight reduction can save 30 to 40% of the energy that you are using in this furnace. So that means a little bit of value. It's called value engineering, where you try to see how much should be the weight of this basket, minimum weight, which can hold this product, and accordingly we keep reducing the weight of the basket. So this is one thing. Then the another important thing when we talk about this, it's worth mentioning, is the capacity utilization. Once you put up a facility, you have to utilize the capacity to its fullest. Suppose I have this big furnace which is meant for 70 kgs, but instead of 70 kgs I am putting only 30 kgs. Then my energy cost will go up. So how to plan, how to schedule the operations? I accumulate some material and then wait for some more jobs, then do the heat treatment in one go. So these are all the things that will have to come in the initial design phase itself. So that will also determine the size of the furnace. If you go in for a bigger equipment, but you're going to use only smaller quantities of work, volumes of work, then the energy consumption is going to be high. So you have to appropriately size the equipment and design the equipment so that your capacity is fully utilized. So capacity utilization is something which you have to keep in mind. Whenever you buy an equipment, the capacity utilization should be near about 100%. So this we have already seen this, the split air conditioner which is used. It is used in the printing process and also used in the houses. So mostly in your offices this may be used. At least 4 or 5 air conditioners will be there in many of the SME industries which holds an office. The biggest problem with the air conditioner is it's an energy guzzler. There is a compressor and it is going to be highly energy intensive for this equipment. So the options as we discussed is in the form of going in for star rated equipment or 5-star rated air conditioner, or going in for an inverter based air conditioners are the most energy efficient. So these are the things that you can consider. Also, when you feel that your operations are going to be air conditioning intensive, let's say you have an office and above the office you have a terrace, a lot of heat load will come into the room through the terrace. Okay, so what we have to do is to prevent the heat coming into the terrace. So probably a white paint on the terrace can dramatically reduce the energy consumption, dramatically reduce the heat coming into the room and reduce the energy consumption for the air conditioner. Or maybe you can have some shading, some trees or some plants which are there on the terrace. They can act as a heat barrier and reduce the consumption of air conditioning. So like this, there are several opportunities, and when you're operating, in the design is these are all things to be considered in the design. When you're operating, better to operate the highest possible temperatures. That means if you're operating at 26 or 27, then your energy consumption can significantly reduce. So the comparison between a non-inverter type of air conditioner. If a non-inverter, that means an AC without inverter, if it is consuming, let's say 100% of energy, then the inverter type will consume only 42% of the energy. So 58% saving compared with the non-inverter type of air conditioner. So going for the best possible designs. And if you want to know what is the most energy efficient equipment which is available in the market, then there is one source which is called the Bureau of Energy Efficiency, bestarlabel.com. This is the website. If you go to this website, then you have all these appliances, the tube lights, refrigerators, air conditioners, pumps, transformers, irrigation pump sets. Like this, several products are there. So the Bureau of Energy Efficiency has made a lot of work, and they've done this kind of a software, a selection process where, you know, if you click this transformer, you want to select the most efficient transformer, and all the manufacturers who are producing that, and which manufacturers got the highest efficiency for the range what you're considering. Similarly for the pumps, for the motors, the lamps. So for everything, most of the appliances are covered under this. So if you have any doubts during the initial phase, which one to select, which is the most energy efficient, I'm not very clear, then simple thing is go to this bestarlabel.com. Then if you're going to be an industrial entrepreneur, then if you're going to have some machines, say molding, a molding machine, an injection molding machine, let us say, if you're going to put up some plastic component manufacturing or any other press you're going to use, what are the different types of equipment available for this? So they can be done through mechanical means, hydraulic means, or 100% purely electric. All movements are controlled by electric, and in hydraulic, some of the movements are controlled by hydraulic oil, which means you will have a hydraulic power pack, a pump which is circulating pressurized hydraulic oil to different parts of the equipment, and mechanical is direct motion that takes place. So if you see what are the advantages, disadvantages in terms of energy efficiency, nowadays many of the machines, they have converted to the servo electric. Even people earlier who were using hydraulic or mechanical or pneumatic, they've all gone into servo electric for a simple reason: it is most energy efficient. The servo is the most energy efficient, and for this one reason, many of the equipments have been converted. Even the manufacturing the machines itself have seen a lot of changes. They're all now based on servo electric. Then the motor. Suppose you are buying an equipment, and along with the equipment comes the motor. The choice is not in your hands. The equipment manufacturer sends the machine along with the motor. But what you can do is, you can tell the equipment manufacturer to provide the most energy efficient motor, even if it involves some additional amount, maybe 10% more it may be involved, but then you have to tell him to supply the equipment with the most energy efficient motor. So in this case, we have the BE has come out with various schemes also we have this table here which indicates, of course it may not be clear, but it's available in the presentation which will be sent to you. So for different kilowatts, what is the normal efficiency? What is the energy efficient motor efficiency? The energy efficient motors are called IE3 motors. So for simplicity, you can tell the equipment supplier that whatever equipment is going to supply, it should be supplied with IE3 motors. These days, many of the major manufacturers are supplying the equipment with IE3 motors. So similarly, you can also insist whether it is a lathe or a CNC machine or a hydraulic power pack or a compressor, whatever it is, whatever be the machine, it should be with IE3. Because in the design stage, it is very simpler to go in for an IE3 motor. Later on, if you buy an old, the conventional motor, and if you want to replace with IE3, it becomes economically unviable. Because there is a 3% or 4% efficiency gap, which will not make it attractive when you want to replace an existing motor with IE3 motor. But when you are purchasing a new equipment, when you buy IE3 motor, it's only the marginal cost, the 10% which is going to be extra. Anyway, you're going to buy a motor. By paying additional 10%, you're going to get an energy efficient motor, IE3 motor. So it makes sense to go in for IE3 motor at the design stage itself. Then every industry will have a DG set, a generator for a standby. So it depends again on the criticality of the process. If you want to have some standby and the process is critical that you cannot stop it, then you can have a DG set. Otherwise, if you feel that, okay, the plant can stop for some time, then the power come will start, then don't buy this. It's a white elephant. So this is again a thing. First, as we said, no, eliminate if possible. Diesel generator is only a standby equipment. Whenever the grid supply, the power supply from KSEB fails, only you're going to operate this equipment. Why do I need this? How often? What is the reliability of KSEB supply? So you have to, in your area, you have to find out what is the reliability. Can I get reliable power? If there is a power cut, what will happen to my equipment? Can it tolerate for about half an hour, 1 hour before the power supply is restored? Or should I immediately start the DG sets to save the process? So all these questions will tell you whether DG set has to be purchased at all. Is it required? If it is not required, eliminate it. Because it's a headache. Because you're not going to use that. It will be used only when there is a power trip or a power failure. So for that, you have to maintain this big elephant, which is not required. But in the worst case, when you feel that this is must, you have to have a DG set. The second question is, what load requires continuous power supply? Where the power supply has to be restored immediately, which are the processes. So only for that, you size the DG set. We don't have to size the DG set for running the entire plant. Only the critical components, critical operations, you size the DG set accordingly so that your initial cost will come down. Then when you're operating a DG set, suppose there is a 8-hour power failure and you want to operate the DG set, it can be quite expensive because the cost of diesel is about 60, let's say 60 rupees. And this DG set is going to give you only maximum 3 units per liter, which means your cost per kilowatt hour per unit is going to be 20 rupees. KSEB power supply may be 6 rupees or 7 rupees, but a DG set power supply is 20 rupees. So it's quite expensive. And so these are the questions that you need to ask when you buy a DG set. The next important thing is the lighting, as we discussed already. The day lighting. There's plenty of light around. We are closing everything and sitting inside in darkness. So when you are constructing the shed, see to it that maximum amount of light passes through the roof, through the sides, so that you don't need to use the daylight, the lamps during the daytime. So this is another important, very simple measure, one-time measure, lifelong we can save energy. At least for 10 hours of operation during the daytime, we need not use these lamps. Also, working in daylight, it's more comfortable than working in under the lamps. So it improves the productivity of the labor who are working here, improves the morale and motivation, and we are making use of the natural light. And the next one is about the welding. We have different kinds of welding equipment. Welding is also slightly energy intensive depending on the nature of use. If it's going to be a continuous use, it can consume considerable amount of energy. So in the selection of welding sets, the conventional welding set used to have this, the thyristor based or rectifier based sets. Let's say if it is consuming about 400 watts for a particular kVA of design. These are the new generation inverter based welding sets. They are more efficient and consume much less energy, maybe 30 to 40% less energy compared to the conventional welding equipment. So wherever you have welding operations and you are in the process of buying a welding machine, then this should be your choice, inverter based. This is an inverter based machine. So, so far we have seen what are the possibilities that exist in the process side, how you can select the equipment, how you can operate the equipment so that overall energy consumption can be minimized and energy efficiency can be incorporated into the design stage itself. That is from the consumption side. Now, from the generation side, we are interested in cost reduction. Though energy efficiency has several benefits, like preventing global warming and extending the resource availability and all that, our focus is on cost reduction. How to reduce our energy cost? That is the object. So what we have seen is all the consuming equipment side, what are all the possibilities that exist. These are all the examples what we have shown, but a wide variety of possibilities available depending on what kind of industries you are going to put up. So here, if you look at this solar photovoltaic system, this is quite common nowadays. We are generating electrical energy through solar photovoltaic, solar energy. So what is the advantage of this? The single most advantage is that is it going to be cheaper than the grid? Is it worthwhile putting it? So there are different models available. You don't have to invest all your money. You can have different models of utilizing solar. Financial models are available. So basically what happened, there is a sun which is containing enormous amount of energy. One type of energy is the photo energy, that is light energy. The light energy comes and strikes the panels and it creates electricity. The photons displace electrons and electron movement creates electricity. And what it creates is a DC. We have to convert it into AC. So we convert it to an inverter, AC supply. You can use it here directly. If you have excess, you supply to the grid. So this is one model. Sunlight hits the panel. This is a solar panel. Generate electricity. DC, it is a direct current. Converted to alternating current, which we are using in our industries and homes. So this, once it is AC, then it can be connected to your internal grid. Your own circuit, it can be connected and you can directly use the energy what is coming in your factory. At the same time, you can also draw the power from the grid. So it will be power from the grid as well as the power from the solar, both together you can consume it. You don't need any storage in this case. Direct connection to the grid connected system. But let's say there is a Sunday you're not operating. It's a holiday for you. What do you do with that energy that is produced? There are two options. One is you supply to the grid, so the grid takes it. But what is the amount that they'll be paying for this supplied energy from you is not much, not very significant. So one option could be that Sunday's energy you can store it through a battery and use it in the subsequent days, Monday, Tuesday and all that. So these are the options that you have to think before putting up the solar energy, whether solar energy is required, solar photo, is it going to make economical sense and is it worthwhile? So these are all the questions that do you have space first? So all these things will need to be considered. And if you see here, there is a rooftop. So here the space is not a problem. Already there is a roof. You have the panels on the roof, and from these roof, it goes to you consume whatever you want, remaining goes to the grid. This is one system. So these are typical panels, how they look like. As you will see in reality, this will be the actual panels. And space is something which is very critical nowadays, especially if you are in the cities. So some of them have become innovative, and whatever the car parking is there, they have provided solar panels on the roof of the car parking shed. So this is one way of mitigating the space problem. The other thing is, suppose if you want to put it a terrace, then the entire terrace area becomes unusable. To overcome this, the panel is elevated. So it is provided a height of, let's say, 8 feet from the ground. So you can continue to use this space. So this becomes a room actually. So you put a panel on top, and this you can use it as a, if you are in industry, you can put this in your terrace and use it for packing or other purpose, or even office. You can use this as an office for your purpose on the terrace. So on the top you have a solar panel. So it generates electricity as well as provides a shade and converts your open terrace into a room. What about the cost? So right now, the cost for solar PV is about 60,000 rupees per kilowatt for grid connected. If you directly connect it to the grid without the battery. With battery, it comes about 80,000 rupees. And there are different models. So one is that you yourself can put up the 60,000 rupees and you have this solar PV installed. Otherwise, there is another model called OPEX model. There are a lot of private players in the market. So where they say, you give us your roof, we will come and put up the panel in your roof, and whatever the energy that we are getting, we'll give it to you at say 1 rupee less than the power you are going to pay to KSEB. This is one model, OPEX model. Now the KSEB itself has come out with some schemes, though they say, the website says it is for domestic. We just need to clarify whether it is applicable for industrial also. So in that, this is called Saura subsidy scheme, as they say. So this is, you can zoom it up later. So basically, it's got different components. You pay partially some cost, KSEB pays some cost, and whatever energy is generated, you can share it. It's a shared model. The other model is, okay, you want to own the system yourself, then you pay some cost and KSEB pays some subsidy. So it is your own system, you have to maintain it and generate the electricity. But in this case, you are partially the owner, KSEB is partially the owner, you are the owner of the rooftop but not the panel. The panel is maintained by KSEB and whatever energy generated is shared. So this is one model. So normally 1 kilowatt of solar PV can generate about 4 to 5 units per day. So this is the generation rate, and you can work out the economics. So at the present cost, 60,000 is the present cost per kilowatt and 4 to 5 units per day generation. And at the present energy prices, the payback period will be around 6 to 7 years. So this is the condition. Now here we have solar powered irrigation. For agriculture, how we can utilize solar energy? Say for pumping, you have a panel here and you have a submersible pump. The power is supplied to the pump and then the water is pumped and sent to different sprinkler irrigation systems. Here it becomes even more challenging because the power costs are very low. Already KSEB is charging only 2 rupees 30 paise and your panel cost is going to remain the same, 60,000 rupees. So the economics is not very attractive at today's electricity prices. Whereas for industry, it is, let us say, about 7 rupees. So you compare 7 rupees the industrial electricity units price, 2 rupees 30 paise is the agricultural price. So the payback period will be almost 3 times. So here the payback period, as we see from this, will go up to 20 years. But where it is advantageous, suppose you have a lot of power interruptions and KSEB is not able to lay long power lines into inaccessible areas. So there, isolated cases, whatever be the cost, this is definitely an advantage. The other energy source in the industry, what we have is thermal energy. Whatever we have seen so far is the electrical energy per part. Now, thermal energy, many of the industries may use steam. Suppose, especially if you are a food processing industry, steam may be required or hot water may be required. Now, there are different methods by which you can produce thermal energy in the form of steam or hot water. So one is you have these fuel sources, coal, and then you have firewood, rice husk. These are all different types of bagasse from the sugar mills. There are all different types of solid fuels. And of course, in Kerala, we have coconut shells, then coconut husk, the fiber part. So here you can see this is a boiler. A boiler is burning purely with coconut shell. The coconut shell is a very good fuel. It's got a very high calorific value. So it's a very popular fuel. But in many of the cases, the coconut shell also gives you a value-added product, which is the charcoal. So from coconut shell, you can convert that into charcoal, which is used in many of the water treatment applications. For removal of odor from the water, this charcoal is used and there's a huge demand for this. So coconut shell mostly is converted to charcoal. And liquid fuels, we have diesel is the main fuel. Furnace oil, if you have quite substantial consumption, If you have a huge consumption, you can use furnace oil. It is cheaper. Say it will be 25 rupees per liter. Diesel will be 60 rupees per liter. Then there is a fuel called LDO, which is a mix of diesel and furnace oil. It is about again about 50 rupees per liter. So depending on what is your need then, whether we should go in for a solid fuel fired boiler or a liquid fuel fired boiler. Suppose your operation is going to be only for 2 hours a day, then there is no point in going for solid fuel, because to start the boiler itself will take about 2 to 3 hours. So it doesn't make sense, and your consumption also will be high during startups and shutdowns. So liquid fuel, even though the fuel price is high, still it will be economic. But if there is a continuous activity, continuous steam or hot water is required, then preferably solid fuel can be used. And in some parts of Kerala, you also have natural gas available. From Cochin area, you have natural gas. LPG is another fuel which is available for a long time. To the refinery it comes. Then you have biogas. Biogas is basically the methanation process which happens when you put some waste into this closed system. So the biogas evolves, and this biogas will be used for various applications. Now, if you want steam or hot water, you can also do it by solar or the renewable energy sources. One of the renewables we saw is the biogas. Biogas can utilize any kind of waste, say kitchen waste or the waste material from the trees. Anything can be used. The other renewable source for steam or hot water is the solar collectors. So this is a high temperature steam or thermic fluid with parabolic collectors. Now here, this is a parabolic collector. The sunlight comes and falls on the parabolic collector, and then it reflects back into this pipeline. So all the reflections are focused on this pipeline. So cold water goes here, slowly, progressively becomes hot, becomes steam at the outlet. This is a steam generator. So you can also use oils, say thermic oil, thermic fluid oil, which will go into this, heat up to maybe 200, 300 degrees centigrade, using which you can even take it to the kitchen to fry papad or make vadas. So everything is possible with this solar when you have a concentrator. This is again a solar boiler where you have a parabolic dish. So all the reflected heat rays are focused on one point. So water goes inside, converts into steam and comes out. So this is also a possibility, but it can be quite expensive. Beyond energy, one more important thing that you need to focus on is how you will minimize your wastages. There is nothing called a wastage. Everything is a purposeful raw material. What is waste for you may be a raw material for the other factory. So in the printing press case, again, it's a simple process, so we're taking the process. So here it is a carton. This is a carton box made for one company. Now this carton box wanted to have a slit here, so one cutting is made in this part, and a polythene paper is covered on this. So just to see what is the color of the cloth inside. Now what happens to this cut piece? So this already it is made, and now this cutting of this portion of carton is going to be done. What happens to that piece? So that piece is going to be like this. So punched cutting. Now how there are thousands of pieces are coming out of this product. can we effectively utilize this for some other purpose? Now today they are throwing it into the waste, and then the waste paper man comes and picks it up for a very nominal rate. He is taking the wastages. So instead, you can use it as a billing tag. So you provide the price rate in this, and then you can attach to that a cloth or some other product. So as a price tag. So have a tag, use it as a tag, so it can be directly used as a product. Similarly, the other cuttings. So one more carton has got this kind of a shape of a cutting. So we need to identify how we can effectively utilize this kind of waste, which are otherwise thrown to the waste paper man, and he will send it to a pulp factory, a paper factory, where it will be again dissolved, made into a pulp, again paper or carton will be made. So you see that a wastage in the whole process. So similarly, this is another cutting which is there, how to make use of this product. So there are several innovative thoughts that can come once you have maybe thousands of pieces like this. So how, instead of throwing it and pulping it, can we directly put this to some use? And when we talk about products, the innovative nature of the products, there is infinite dimensions it can go. Then here is a simple thing that was done quite a few years back. This is that muringai tree, drumstick tree, and that is made into a powder, and then the powder is packed, and then it's all exported all over the world now. So it's a harmless, uncared for drumstick tree. Today it is fetching several thousands of dollars in foreign exchange by exports. So in this process, because healthcare is another important industry, people are now more worried about the health. So everybody's talking about the health, and so the saleability of these kind of products are going to be on the rise. So again, in this process, how we can convert this leaf into powder with a neat packing. In between, several processes will come. You have to dry the leaves, and then you have to powder the leaves. Then there has to be a sorting, grading, and then packing. So in all these operations, we have to see what is the energy component, how we can reduce, minimize, or how we can increase the productivity, how we can improve the production, how we can minimize the wastages. So all these things we start questioning, then we end up with the most energy efficient design of the factory. Okay, so these are all the things that I wanted to share with you. Of course, you may have many questions. Since we are almost running out of time, probably the questions can be made, and we'll try to answer it through your respective mails or through the websites. Okay, so with this, I conclude my lecture. Thank you very much for the opportunity given, and I wish all the entrepreneurs who are going to start their initiatives all the very best. And I hope you will make use of this little inputs, which whatever knowledge I had to share. I'm sure you'll all benefit and become successful. So thank you very much. Hello?
Nagesh sir,
Yeah.
can we conclude, sir?
Yeah, you can conclude. I've finished. So I'm thanking everybody and also the EMC for the opportunity given to me, and it was a pleasure talking to you. Thank you very much.
Sir, a lot of participants are asking lots of doubts. We will send you, sir.
All the questions will be answered.
Okay.
Yeah.
And we will publish a booklet also, sir. Frequently asked questions.
Yeah.
Thank you, sir. Thank you for your time, sir.
Thank you very much, Rajiv.
And I would like to extend my sincere thanks to all the participants who have been here. And expecting this participation in the future presentations also. And also thanks to my TMK team for your support. Thank you.